Life originates from water and sunlight. Sunlight breaks down to give a palette of colour. And the most colourful ecosystem on our planet is underwater, on the coral reef. In a world dominated by animals bathed in permanent blue light, what are the animals really saying? In an environment ruled by predators searching for prey, why do they harbour such conspicuous colours? What would it take to see their world from a different point of view? Join us on a kaleidoscopic journey of discovery as we search for the meaning of watercolours. Entering an alien world, we're confronted by vibrant colour and display. A world where each fish tries to be brighter than the next. Why such conspicuous fish? When surely this should be dangerous. Could things be different to what we perceive? What really does all this colour mean? How much of what we see is an illusion? Fascinated by the fish's incredible colours, fish behaviourists Guy and Anita are embarking on a quest to find their meaning. It'll take a wild, epic, 3-year journey to understand. In their quest for answers, the team are travelling far from the modern world, to a land halted in time and steeped in tradition. Like an iceberg, the best of the Pacific Islands lies below the waterline. Where better to study colour display, understand why fish are so colourful, and reveal their deepest secret, which will forever change the way we see them. It's obvious when diving on a coral reef that colours are very important. What's less clear is why some fish stand out like a beacon, while others prefer to blend with their environment to the extent that they disappear. Looking into their motivation, easy answers come to us. Some fish want to be seen and stand out from others in order to mate. Highly contrasting, saturated colours are chosen. Others need to camouflage themselves to feed or evade predation. Concealment is achieved by blending into their environment. But some fish wear such bright, vibrant colours that we can't make sense of them at all. Perhaps to understand these colours, we should start by understanding how we see colour. Our eyes have colour receptors in 3 different channels or wavelengths. we see red, green and blue. Three primary colours which combine to reveal colours from red to violet, our entire visual spectrum. We see the reef predominantly as yellowish-brown. This due to zooxanthellae living in the coral's tissues. The most dominant fish's colours seem to be yellow and blue. Blue fish, yellow fish, and all possible combinations are displayed. It seems the yellows of the reef and the blues of the ocean give the coral reef creatures their major colour theme. As we observe, the yellow fish stick to the coral bed, while blue fish seem more comfortable high above the reef in open water. A lot of blue and yellow fish in a blue and yellow world. Does it stand to reason these fish are trying to blend with their backgrounds? Or conversely, are they trying to stand out against it? Underwater colour proves a subject barely approached. Research points to Professor Justin Marshall, the world's leading research scientist on the subject. Wondering why so many fish are blue and yellow, we turn to the professor for answers.
It's a very common theme on the reef, and it's a very interesting question, especially when you compare reef fish to other fish populations such as those in freshwater. So in freshwater, fish are often green and red. On the reef, they're yellow and blue, and it's for the reason that yellow and blue transmit well in reef water. So it's a good way of transmitting a signal over a long distance. And that's why through evolution their colours have become refined to be very often combinations of yellow and blue.
Multicoloured fish rise above the corals, feeding, displaying, advertising. As key approaches, they hide in the coral branches. But the branches don't seem to protect by structure alone. In fact, the yellow fish position themselves next to the coral. The blue fish stay way higher. As the predator scans the reef, the fish are inconspicuous. It appears fish are positioning themselves, cleverly using their colours and background to either be flashy or disguised. This is incredible insight into a skillful, social use of colour. But despite relentless observation, there's still many unanswered questions. Blue and yellow fish are everywhere. Their colours are making sense. But then there are the others. All the colours of the visible spectrum are in use, with some of the reef's inhabitants wearing brightly extreme combinations. Why such conspicuously coloured fish? When we look at the reef, we're faced with a paradox. How can all these fish manage to hide from their predator and simultaneously be obvious to a mate?
You might think that a very conspicuous fish would be an obvious target for a predator. However, those brightly coloured fish are relatively well camouflaged against their background for two reasons. Firstly, the bright colours match the background against which they appear, and secondly, the visual system of the predators, such as barracuda, coral trout, other big fish that might want to eat them, is not well adapted to pick out the colours that we see. For us as primates, essentially monkeys swimming underwater, many of the colours, for instance the yellows, the oranges, the reds, appear very conspicuous to us because they're just like ripening fruit. And for a primate, for a monkey, ripe fruit is an important aspect of survival. For a fish on the reef, ripe fruit doesn't really matter.
So colours don't appear as impressive to some as they do to others. Then what really does all this colour mean? Over the years, great biologists have found numerous theories. One was that corals, anemones and fish exhibit a colourful drama to warn that they're toxic. But the anemone fish, for example, wear highly contrasted colours, and they're not toxic. Another theory is of colour for camouflage. But it seems impossible that some of them could blend with any background. It's been suggested that fish use colour to highlight territorial boundaries. But butterfly fish are perhaps the most boldly coloured of all, and they're not territorial. Perhaps like birds in sexual selection, colour is a trick to bewitch a mate. But underwater, the male and female often appear the same. Distinguishing each other, setting up territories, attracting mates, even highlighting weapons. Why does the coral reef provide such highly conspicuous fish? Yet simultaneously others as camouflaged as the scorpionfish. As the team go through the theories behind this stunning colour, there's always something that doesn't hold true. Is it possible that thinking there's only one meaning is the source of all the confusion?
Oira mai na via nialu eranda uraidira lake na tukandra bogavida e na bugulika merakela. Okoangona na mbula e bunga mai e waitui. Ele butalangana santaro e na saumi makia.
What if the reasons for the diversity of colour are as diverse as the fish's colours themselves? Blue fish are camouflaged against the blue. Yellow fish are all over the reef. We're sure they're expertly using their colours to show off or be camouflaged. But how can the other extreme multicoloured fish blend with any background at all? Continually studying the animal's colour, position and behaviour, he's had an idea. A snake is boldly coloured and vividly patterned. Yet in his jungle environment, he disappears in plain view. In a high-contrast, multicoloured world, he wonders, is it possible these vibrantly coloured fish could actually be disguised, like a snake in the jungle or a soldier wearing camouflage?
It's time to turn to the professor again.
Brightly coloured fish on the reef have many different strategies for survival, so surprisingly those bright colours are actually relatively good camouflage for some fish. The bold stripes and spots that you see on reef fish match their background well, so you always have to put the fish in the context of its background. Don't just look at a photograph of a fish and assume that that's the way it is. What you need to remember is the background against which the fish appears. This is critical to its survival. A fish which appears against a very contrasting coral head, some nice acropora with branches, some staghorn coral, very often those fish are stripy. And they're stripy because they know their background is stripy. Fish know about what background they're being seen against. If you place a boldly striped animal in a boldly striped background, it tends to disappear. And this is called the principle of disruption or disruptive camouflage. And this is not so obvious to us because you dive on the reef, you see all these wonderful coloured fish, and you think, my goodness, they're all conspicuous, they're all displaying, they're all talking to each other. But in fact, because the fish's perspective is different to ours, to them, many of those colours, many of those bright stripes and spots are actually very effective camouflage. So the background of the fish is critical when you're thinking about why they're coloured the way they are.
So in fact, Guy was right. Looking at the reef as a whole picture, rather than isolating a fish, reveals a very different point of view. Indeed, the yellow goatfish stand out vibrantly against a blue background. Yet over the sandy feeding grounds, they blend in perfect disguise. The queen triggerfish spends most of his time on the plateau looking for food. Using disruptive blue patterns on the upper side of his body and yellows on the underside, viewed through a fish's eyes, he expertly blends his multicoloured silhouette with the reef. So perhaps all fish can be well camouflaged. But astonishingly, perhaps those that are the most colourful are the most camouflaged of all. The fish's dazzling shades and patterns are incredible to our eyes. But what does a butterfly fish look like to another butterfly fish? How does a parrotfish appear to a shark? What do these animals actually look like to each other? Is it possible that marine animals see their world and each other differently to the way we do?
Absolutely, animals see completely different to humans. It's one of the things which, as a scientist, you begin to realise that most animals on the planet can see the world very often better than we can. They have more colour photoreceptors, they see the world in more detail than we do, and they see the world very differently to the way that we do. So it's important not to approach different habitats such as the reef and believe that the way that we see it is the way that other animals see it.
So marine animals do see differently, perceive their world from a different point of view. We've understood the ingenious significance of blues and yellows, and that fish change their background depending on how they want to look. We've understood that even the brightest, most boldly coloured fish can be camouflaged, like snakes in the jungle. So our paradox actually makes sense. By cleverly manipulating colours, background, and position, marine animals can feed, hide from their predator, and simultaneously be obvious to a mate. This is a landmark breakthrough in understanding the fish's colours. But arguably, how can we fully understand their significance without knowing how the fish see each other and themselves?
To understand fish's colours, you have to realise that the way fish see other fish is completely different to the way that we see them. Their experience of themselves is absolutely different to our experience of them. We are primates, we're monkeys, we go to the water, we see their colours from our perspective. We're quite good at yellows and oranges and reds, for instance. The reef fish out there are much more centred on ultraviolet blue and green, so their spectrum of life is shifted compared to ours.
These red and orange fish really stand out. But for a fish with diminished sensitivity in reds, they're not nearly as conspicuous. In fact, blending with the background, they're actually hard to see. It's the same for the yellows. We see all variations. But for fish lacking our yellow visual separation, bright yellows are not nearly as bright.
The fish's visual system, its eyes are tuned to parts of the spectrum, parts of the rainbow that we don't see. And the way that we see fish is very much human-centred.
Looking into the fish's eyes, I wonder what I look like to them.
To get close to a turtle or stingray requires a special approach. The key is to look as harmless as possible. But what do they see?
Perhaps to the fish, their dazzling neighbours are actually quite bland. Sometimes we wonder why a predator doesn't strike such obvious prey. But our eyes are not the ones to give us the answer. Marine animals stimulate our eyes in a kaleidoscope of colour, but they perceive colour and their world in a very different way. Even the brightest colours can be used for camouflage. Colourful animals hiding in plain view. Marine animals manipulate the way they look. They use skill, placement, colour and background to be flashy, disguised, or even both at the same time. Fish's colours have fascinated us for centuries. We had no idea of the extent of their significance. Colour is an integral part of marine animals' social behaviour. In this world of fascinating illusion, if we can see how they appear to each other, perhaps we'll see a world we can start to understand.